Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullah. So today we are conducting online for this system design. All right. I believe I already mentioned to you guys to prepare your PDS. I hope all the group have completed PDS. It means your PDS must be in detail at least 4 pages. All right. At this moment, you have already completed your PDS, and after you have completed PDS, because PDS, the work that you do to form the PDS, I have mentioned before, you cannot form the PDS you have done earlier empty-handed. It means that all of the group members have done information search, have done background studies, have done visiting the site, the case of your project. So each group member already done search information. I already explained to you sources of information and how to form the PDS, and you have a lot of information, site visit. Maybe some of you, each one of you must do search from patterns, from standard, from legislation, from supplier, manufacturer, existing product, all sources of information. Then after you have collected all the information, and then you will sit down together and you will form the PDS, because PDS cannot be formed each one of you empty-handed. So it means each one of you have already have collected information. So that's why if you do it empty-handed, your PDS will become terrible, will become shallow. Your PDS is kind of like not useful. If each of you, of your group member, have collected enough information, strong information, then you form a PDS, then your PDS will be good. All right. Okay, after you have completed your PDS, so I believe at this moment you have already completed your PDS. So it means that PDS, you shared the copy to each of your group members. So each one of you kind like, we call it macam hadam kan, memorize it. You know what's the list, because what the list, the statement that you have already put in your PDS, because your PDS will be your sources, your guide. It will be the checklist. It will be your guidelines. It will be your all the design requirement, all the thing requirement that you need to design, is everything is listed in PDS under the proper heading like performance, size, cost, and so on. I already explained about that. So it will become your reference, because PDS will make sure either your conceptual after this. Today I want to more explain about conceptual design stage, and we want you have a good foundation. Okay, your PDS is your foundation. If your PDS is shallow, PDS is weak, so it means foundation is weak. It means that through the process of the rest of the engineering design process, conceptual design, detail design, and so on, so it will be it will affect the output of the outcome, your everything, your final concept, and so on. So make sure your PDS is good, and your PDS, after you have done, you must refer to the PDS. It's very not just throw away, because lecturer us, we already done, we submit PDS, that's it. No, PDS is your reference. You must read the PDS. Each one of the group member read the PDS. You understand what's the story inside, what is the design requirement, what is the, everything is there, right? Okay, once your PDS is completed, okay, now, okay, this is, as you can see in my video, so this is your PDS. Okay, you already done, completed, detailed PDS. What I want to be detailed PDS. Then only we go for conceptual design stage, all right? Conceptual design. So now we are on conceptual design. So this conceptual design where we will generate ideas, all right? We will generate ideas. Okay, we will generate ideas. You will generate a lot of concepts, because since one group consists of 5, maybe 6, so let's say it's about 6, so you say the ideas, not one idea. It means each group member have to produce at least 3 concepts. If your group consists of 5, it means you have 15 concepts generated by your group. So that is better, because you will produce groups. So student A, student B, student C, student D, student E will produce 3 concepts, right? Will produce 3 concepts. Produce 3 concepts. All right, you have concept concept 1 to 3, concept 1 to 3, concept 1 to 3. Each one of the group member will produce 3 concepts. So you have 15 concepts. Then you will do evaluation. Later next week we go for evaluation, how we will select the final ideas. All right, talking about conceptual design, this is the most we call the hot stage in engineering design process, because this is the main thing, conceptual design, where we will generate ideas. So it means it depends on your PDS. As I mentioned before, PDS very important. So each one of you already read the PDS, have the same, each one of you have a copy of PDS. So it means that student A, B, C, D, and E can independently generate 3 concepts, will not depend on the other group members. Okay, so it means the foundation, each one of you is strong because all of you have same amount of knowledge. Why you have same amount of knowledge? Because you have produced the PDS. Each one of you have a copy of it. I already read it and kind of memorized. You must bring it with you. So you can independently generate concepts. All right, okay. In this conceptual design, we generate ideas. So there's a lot of way of generate ideas, but the main thing, there's a lot of methods to do that, to generate concepts. But what I'm going to tell you is about, I think you have already learned, we will do on method. So the method of generating concept, we will do for function decomposition. We are now under conceptual design stage. We will do function decomposition. Because at this stage, about concept generation is about creativity, how we generate ideas. It's kind of like about problem solving. Actually, there's a lot of methods. You can look on, for example, you can look another method. Actually, TRIS is invention, theory of invention. It's about, TRIS is a lot of method. Actually, TRIS actually developed by Russian, because they just actually part function decomposition that I'm going to explain to you, and morphological function decomposition. Position, and you will do morphological chart. All right, so this is also part of morphological chart. When you learn TRIS, another theory of, there's a lot of theory technique how to solve a problem. TRIS actually, they kind of like, if I'm not mistaken, kind of like have 40 principle how to solve a problem. One of the principle is function decomposition and morphological chart. So this is a main thing you will do. Okay, how you solve a problem, because you cannot solve a problem start from the beginning, because you have to be have gone through the design stages. Like for example, you at the moment you have produced a PDS, right? So then only you can develop ideas, you can generate ideas. So we will do function decomposition and morphological chart. All right. So what you will do, function decomposition and morphological charts means that, so you will generate, because each of the group, I believe, different title. So it's kind of difficult for me to kind of like coordinate, and because different group, different titles. So it means that each one of you have to think about your project, how you going to solve the problems by doing function decomposition. Function decomposition is a technique. We decompose our total function of our machine you're going to design, or device you're going to design, into sub-function and sub-function. All right, function and sub-function. For example, like this. Okay, previously, like, okay, guys, yeah. Right, line, okay, I keep interrupting because sometimes when we're doing online, I've been talking, actually, you cannot hear me. Line, okay? Please respond. Line is good on my. Hear my
Yes, yes.
voice?
Boleh tak, Tan?
Class, I'm asking you. Boleh dengar saya?
Boleh dengar.
Okay.
Boleh, boleh. Total boleh.
Boleh.
Right. Okay. Function decomposition means you start from the black box. For example, like this beach cleaning, for example, like beach cleaning device. So I believe this is a previous semester beach cleaning device. So this is beach cleaning device. So we start from like this. So let's say your project, I give you one sample example of a project. Previous semester, my student doing beach cleaning device, one of the group. So you start from a black box, all right? A black box. So you have an input, and you have an output. You think about your project like this. So the black box is about your project. It's your project title, okay? Like this one, the black box, this is beach cleaning about the black box, and this is the output. Okay, the output. Okay, when talking about beach cleaning device, you have to sit down together. This is a group work. It cannot be because as I mentioned earlier, you can independently after you have completed PDS. So each one of you have the same copy. It means each of the group member can independently generate 3 ideas. Okay, that's good also. You can do it this way, but more systematic, you do it like this. First, there is a group work, so you sit down together. Okay, you don't have to wait for next week. If you have time, you can do it this week. Access to any whiteboard, you sit down together as a group. You can go to anywhere, bring a big size of paper, but better to be whiteboard if you can access whiteboard. You bring marker and you sit down together. So you do it like this. So you have to function decomposition. So it means you take, for example, like beach cleaning device. Okay, beach cleaning device, the student have to design the machine or device on the beach, that the idea of the device or the machine is to collect all the waste have been thrown on the beach by the tourists, right? Waste like plastic bag, bottle can, bottle container, okay? Plastic bottle, plastic bag, aluminium can, and so on, all the waste, garbage on the beach. So the device have to collect to make sure that the beach is clean. So the input like this. So this is a black box. Black box is a whole system. So this is a whole system. So you mean you have to disintegrate. You have to decompose it into sub-function. So it means the input of base cleaning device is beach sand. Okay, there is beach sand because the device, the input. What is the input of your device? The beach sand will be input because of course the machine or device will collect all the garbage, the waste, plus the beach sand will be sucked into the device, right? Beach sand plus the waste. Waste is what we are going to collect. Waste, I mean the plastic can, aluminum can, plastic bottle, plastic bag, and so on. Because of course the device can like excavate, it will bring all together, and the output of the machine, it means, hold on. Hold on, class. Ada something else. Hold on. So, all right. The input of this is your black box. The input will be Bison plus the waste. The output will be the output means that output from your machine is not actually the collected waste. It will be the Bison. Okay, it will be the Bison. Bison I will explain to you later. So this kind of like complete function of this case beach cleaning device. So it means that for example, like if we go for you might not understand what I'm talking about. So this is your system. For example, if you want to design a washing machine, your black box. So this will be your washing machine. So your input will be dirty clothes. Your output will be clean clothes, right? Clean clothes. That is your machine. You want to design a new washing machine. So this is your black box. So you will integrate all the function into flow of sub-function. What sub-function that is happening inside a washing machine? First, we have what we call it a washing unit. We have a rinsing unit. We have a what we call it. Because you have to divide this into sub-function and sub-function, right? Washing machine, we have rinsing, we have cleaning, we have water out, water in, and at the end. So you kind of have a flow chart of sub-function to make a complete system where the input, dirty clothes, and the output is clean clothes, right? So I don't have time to explain to you about this washing machine, what I'm focused on about beach cleaning device. So this will be your black box. So you have to, this is a black box. So you have not decompose it into sub-function and sub-function. So you sit down together about, okay, your case is not beach cleaning. This is as example, as a guideline for you. So what you will do, then you will, okay, you sit down together. So your input is Bsen plus waste, your output is a Bsen. So it means something inside here, the device is already collected the waste, all the garbage on the beach, right? So the out throw away all the Bsen. So this is how you're going to design this. So you sit down together. So that's why you call it black box. So you decompose it. Okay. We compose it into. So you sit down together. You on the whiteboard. You write all possible function that will happen in your machine. For example, we want to design a. This is all based on you have already read. Each one of you have good amount of knowledge because you are already well prepared by reading the PDS through your background studies and so on. So you have kind of like enough information to discuss about what will be going to be the subfunction involved. So it means each of group member, each of the group will contribute ideas on the whiteboard, writing all the possible functions. Somebody will say it. We will collect the waste. The waste must always, when we collect the waste, we will excavate. We do excavate, kind like we excavate the bisen, and together with the waste, we excavate bisen plus waste, because we need to collect the waste on the bisen. So we sometimes we need to convey. We have to convey the waste plus bisen, then we convey. After we convey, so this through kind like we call it generally we can say brainstorming. You put all the possible thing function. This is all about function. All the word is it's not about adjective. It's a word of what will be the function that will be involved of your machine. Convey waste. So because since you've been thinking, because all the group members kind like what is a possible thing involved, kind like what will be the function, the what will be the kind like will be happening inside your machine. Conveying waste. So we will do kind like we will containing first. We will contain the waste. We will, it's not in order. Then we will throw the bisen, throw away. The word don't have to be really good word. Sometimes it's you can do any kind of what informal word. Throw away the bisen. Throw away the bisen after the waste is contained. So we will convey. Somebody will with inside. We will have something like we will separating. We will separate the waste. The waste from the bisen, because at the beginning the bisen is conveyed along together with the waste. Then later on we will separate the waste from the bisen, and then we will contain the waste already there. Then we throw away the waste. So you put all the possible function. Just jot it down. The word of function. You just throw it and write it down on the whiteboard. Understand me? Do you understand, class? Boleh Class? Okay, line okay.
Yes.
Okay, Clara, okay, you understand. You just put all the possible function. This is based on your already, you have enough knowledge, because you are not start from zero, because you already read the PDS. So you throw all the possible function that will be happen in your machine, your device, what you're going to design, right? Because at this moment also you can think about kind of possible solution. Solution doesn't mean that overall something that integrate part of solution that will be involved in your this design of your machine. So you throw all the possible function, then you have a lot of word here in terms of functioning. Maybe some of you said cutting the waste to make it small pieces. Maybe chopping the waste. Somebody said rotating. There is a lot of word of possible function, because I show you just a simple form, right? I just show you simple. You have a lot. Put it all the possible word. It might be happen in your system, right? So then, after you have a lot of word of function, you put it on the white. Guys, this cannot be done on what I show you is A3 paper, but it cannot be done. You preferably you go for, if you cannot access a whiteboard, you go on a big paper and you write it down. Better to be whiteboard, because you will sit down together. This the environment don't have to be in the classroom. Sometimes you have to be informal places. Maybe you can makan minum. Maybe at the cafe, if the cafe has a whiteboard, who knows? Maybe at Zeus Coffee have a whiteboard. You bring a portable whiteboard and sit down together while drinking coffee. It kind like we call it the environment kind like apa kita cakap environment like friendly environment. You enjoy the environment. You can minum, you can laughing and so on. Understand? You do have to be kind like in a constrained environment, right? Because you spend a lot of time doing this. You write all the possible function, then you rearrange because all the have to not necessarily have kind like have the same meaning you can put into category. You have on the same category. So you will rearrange that word. So you will rearrange that word. Then it means that you make kind like, you put it into category and you kind like put it into flowchart based on the sequence of step or order of the system, right? Something like this. Something like this. So you rearrange and put all because at the beginning you have a lot of words, certain words have to be, is there, you have a lot of word of function, then you will decide, you rearrange. Certain word can be falling into category. Certain word have be falling into category. So like this. So you rearrange all the word, you make it into category. At the end, you have something like this. First is kind of like collecting the waste. Collecting the waste plus beach sand. BS is beach sand, beach, pasir pantai, beach sand. Collecting the waste because we need to collect the waste from the beach sand. Okay, collecting the waste. Okay, you will make in order conveying the waste plus beach sand. Then at the end, you will go for conveying the waste, and then maybe you will go for, after we convey the waste plus we send, we will go for separating, right? Separating. We need to separating the waste from sand. Then kemudian after we separating the waste from sand, we need to containing the waste. We need to containing the waste. I mean, because the idea of this basically device is to contain the waste. I mean, the waste have to be contained into the plastic bag or any kind of container to contain the waste. The idea is to remove the waste from the bison, containing the waste. And another thing you can put, removing the bison, because the bison is still inside the machine or device, so we need to throw the bison onto the beach, right? Remove onto the beach bison. And so you have kind of like a flow like this. You rearrange, but all the word you put into category, and at the end you rearrange. Then you have kind of like your sub-function to be the flow is like this. This is based on your discussion. This is what we call it function decomposition. So you agree on this thing because you have previously you have put a lot of word in terms of function. Then you rearrange, you group it into what category. Maybe certain word as a function falling into the same category. Then at the end, you make a categorization of this, and so you make it in order. So you have the kind like this. So it means that, so this is supposed to be 1, this is supposed to be step 2, 3, and 4. This is sequence. That's what we call the function decomposition. So it means at the beginning, we have like this, right? We have, okay, at the beginning, we have like this. We have beach sand plus waste. Beach sand plus waste. Output is we have beach sand. So me and beach sand have been thrown. The device, one is been pulled by tractor or you pull by hand. At the end, the beach sand is thrown out, and all the content of the waste is inside your device, and it contained into the plastic bag. So that's the idea of it. So at the beginning, it's a black box, right? At box, so then you decompose it. You make a brainstorm, you throw out what is the possible function word, then you make into category like this, then you categorize it, then you make it into order. So you agree with your group, so you make into order, so this is the flow of it. So then only you do it like this, right? So then here, here you make function equal. So the one is collecting the waste. So it means that you already agreed. So the first we need to collect the waste. Okay, we need to collect the waste. Okay, the first thing we need to collect the waste, because the idea is this is a black box. Input is this waste plus send. So it means this is at the beginning. This will be your black box, right? Black box. So yang ni the output is send. Alright. The output is send. Okay, at the beginning, this is send plus waste. This is send together plus waste. So the send the input of your machine, it means you kind of excavating. So you reorder based on here. So here will be number one, collecting the waste. So this one, how you collect. Okay, how you collect the waste. Okay, how you collect the waste. Okay, how you collect the waste. You collect, collect the waste plus send. Collect the waste plus send. And here, how you conveying the waste. How you conveying the waste plus send. And here, number 3 is with separating. Separating. All the way is about function. It's kind of separating the waste. You separating, because second is you convey, bring together the waste plus the send. The first one is collect. Collect mean kan maybe we can do by excavating, we can do by sweeping on the beach, we can do by suction, we collect. Convey mean we convey. How we can use conveyor, maybe we can use a screw conveyor, maybe we can use based on a simple tube and so on. That's why we generate this. We have a lot of alternatives because we divide it, we make it into sub-function, and sub-function. The third one would be separating the waste from the send, and number 4, containing the waste, containing the waste. Okay, so this is what we call function decomposition, and the output is removing the send. Okay, containing the waste and removing the send. So it means like this. So it means I have another step here. So this one is removing the send. Okay, removing the send. So like this. So that means the output will be the beach sand. So that's how we do the function decomposition. Okay, that's how we do the function decomposition. So you agree, so you have done this. From the black box, you make a function decomposition. Input sand plus waste, the output is sand. Okay, after you have done this, so this is what you call function decomposition. You integrate of the black box, you kind of like make it into, you decompose it. You decompose it into subsequent of sub-function and sub-function. So this is a complete system. All right, then, okay, after you have done this, so this will be your guide for you to do the morphological chart. So this is a guide for you to do the morphological chart. Okay, I show you morphological chart is like this. Morphological chart. All right, class. Okay, line okay.
Okay.
Everything okay, class?
Yes.
All right, good. Okay, then you have your function decomposition. So you do on the whiteboard also. Okay, better to be a whiteboard, or you have a big size of paper. Then what you will do morphological chart. Because the function decomposition and morphological chart, you will do boleh nampak morphological chart, right? So what you will do morphological chart like this on the whiteboard, preferably on the whiteboard. Okay, you will do it like this. So you have here is ideas. Okay, this all the function of your function decomposition. Okay. Okay, this is all the, oh, sorry, my mistake, guys. This is the sub-function here. This is all the function, right? So this is a function. So this is an idea that you can throw away. So, okay, onto the whiteboard. So you have a lot of rows. Okay, you have rows. Okay, morphological chart cannot be rows. At least must be 5 and 6, guys. At least 5 and 6. Cannot be just 3 columns. You have to idea 1, idea 2, idea 3, idea 4, idea 6, like this. Better to be at least 5 or 6 column, and much apa? You have a lot more column is much better, right? Okay, so the function here that you already put here. Okay, first you have already the flow, collect the waste plus descent. So you put it here. Okay, sometimes because since this is device, because beach cleaning device is kind like a vehicle. It's kind like moving, either pulling by hand or maybe pulling by a beach tractor, beach vehicle. We cannot use passenger vehicle on the beach. The only allows is a tractor that have a PTO at the end. It can pull your device. So that is something missing about this function decomposition. It means that we need to introduce a certain thing. You already made the function decomposition. What I mean here at the first, because this is a function, so I leave the first row blank here. The first row blank because they will become a prime mover. So what will the source of power to drive your device, because is your device is a self-moving vehicle like AGV or so on, or is it pulling by tractor? So we need to put prime mover. Prime mover is the source of either it's pulling by tractor or it's pulling by hand and so on to collect the waste. Okay, here the second one. Okay, the second row is about all your function decomposition that you already agreed with your group. Okay, first is about collect the waste by descent. So here is about collect the waste plus the beach sand. So this will be, you make a row like this, right? You make a row like this. The second one is about conveying the waste. Conveying the waste plus beach sand. I mean, we convey. First collect, then we convey, right? So this will be your second row. So kind of like crooked my line here. So this would be your, right? Then the third one is separating the waste from the descent. Separating the waste from the descent, right? Separating the waste, and the fourth one is containing the waste. Containing the waste. Containing the waste. Containing the waste, and the last one. Okay, the last one is. Okay, the last one containing waste and removing the descent. All right. The last one is removing. How do we remove? Removing the descent. So it means the waste already contained inside your device, maybe in plastic bag or maybe in a tank, in a container, and so on. So you have a lot of alternatives. Okay, clear, guys. So you have so you make this morphological chart. Clear, class? Line okay?
Yes,
Line
yes.
okay ke? Boleh? Can still hear me? Boleh dengar saya? Still okay. I need to ask you guys because sometimes I've been talking, you cannot hear me. Line okay ke?
Yeah, okay.
Respond please.
Okay, boleh.
Can you hear me now? Class, can you still hear me or not?
Can.
Yes,
Okay.
yes.
Yes.
Nobody is answering?
I think you need to turn the volume up a bit, Doctor. Is that clear? on your side.
Okay.
Boleh.
Okay, after you have completed your morphological chart, so you will, this on the whiteboard, preferably on the whiteboard class. So you will throw all the ideas. Okay. So you will throw all the ideas. Okay, prime mover is something about the device. Basically, the device, I mean the device, how do we, something got to move the device or your machine. A prime mover, that it means that once it's moving, it can collect the waste plus the descent, right? So some of you may be using tractor. Prime mover is from tractor, right? From the prime mover is from beach tractor. You just make it. Sometimes you don't have to write. You don't have to. You don't have to sketch idea on the side. So these guys, all the column you throw, you do it based on. Do not do it like this. Do not do it. Okay, prime mover. You throw it here, throw it here. Do not based on column. Based on first subfunction first, because we agree the first one about prime mover. So you based on row. So each one of you put into the cell about what will be the prime mover. Okay, so somebody said pull by standard beach tractor, right? So beach tractor, actually they have output PTO, PTO power transmission output. Then it have kind like to drive your machine and pull, right? And this one we said the device itself can be pulled by hand, pulled by human. Okay, pulled by operator. Pulled by operator, it means it's not pulled by tractor. So pulled by operator. So it means the prime mover pulled by operator. So it means we kind like have what type of prime mover to move the device. So we have a standard wheel, or maybe we have kind like we have to use pulled by operator, and you make a sketch. I mean at your device we have kind of a caster and wheel. Okay, you have caster and wheel. Some of you do it. Okay, you can do some sketch here. So you mean this is, you use 3 wheels, 6 wheel, 4 wheel, or something like that. Or maybe some of you just said prime mover is just a 2-wheeler saja. 2 wheels. So it is your device, and we have a handle to pull by hand. All right. Some of you using a tractor like this, prime mover. So this is a prime between the mover between the beach sand, the ground, the beach sand ground, and also your device. So it kind of like a tractor unit. Kind of you just use kind like more like different approach. Maybe you know, like this kind like tractor, like more on triangle shape. Okay, sometimes like battle tank, they have kind of device. So this kind like primarily, some of you more on is glide on the. We have a rail macam like train, right? We have a rail, so it means the wheel kind like is gliding on the rail. So you put all the sketch. Everybody have to contribute, all right? Contribute, whatever thing. This is not you from zero knowledge. You have amount of knowledge already prepared by how deep is your PDS, as I mentioned earlier. Okay, now it's about the collecting the waste. So this is a prime mover. So what about the collect the waste? Collect the waste is about, because since the device will be pulled by hand, so we already have prime mover source of power. Maybe here about prime mover you have self. So this is AGV. For example, you have pull. This is AGV. Some of it could be AGV. It could be. It means the device itself have the operator. It will drive your. So you put all. That's a prime mover. So you have a lot of ideas, right? Okay, the next one is about the collect the waste based on your function decomposition. You already agreed first about the collect the waste plus descent. So you just throw, all of you have to contribute to it. How do we collect the waste? How do we collect the waste? Okay, how do we collect the waste? Okay, how we will use excavating. So it means we have an arm here. So we have kind while it's been moving. So you sketch on the whiteboard. It's kind of like, like excavator, you have kind of like excavating arm. So while we are pulling, so that excavating arm will rotate this direction, and it kind of like excavate the descent together with the waste, and it will collect the waste, right? Some of you using, we are not using excavating, we just use by sweeping, like this, sweeping penyapu like this. While we are moving, it kind of like sweep the waste plus the descent to your device. You just write like this, right? Contributor. Some of you collect the beach and the waste by suction airflow. You got the vacuum suction unit. by suction. Some of you, based on different approach, you can draw schematic diagram. It's kind of like more like hydraulic system. Once you pulling, it kind of like, so because I'm doing this alone, guys, it's kind of like hard for me. This is the way. It's kind of like bringing the waste here. You have a hydraulic system. Some of you made on something like a channel here that's kind of like a gear system to collect the waste plus the descent. Some of you based on something like different approach, maybe like tractor excavator, we have hydraulic arm here, like the arm of the excavator of the caterpillar. It's kind of hydraulic to collect the waste and so on. So guys, at least 6 columns, guys. Not if you put 3, 4 columns, it's shallow your PDS. At least 6 columns. Okay, convey the waste. How do we convey the waste plus descent to mean the waste plus the descent have already been collected earlier? Then how do we convey it? How do we convey it? Some of you using a simple conveyor. Put it like that, conveyor. So one of you voice up to do more on screw feeder. We have a screw feeder, so it means the descent together will be conveyed by screw feeder. Some of you will be more a simple tunnel saja, just simple tunnel, and we use kind like a vacuum. Suction, okay, using suction by vacuum, like a vacuum motor, right? Suction to convey the waste. Some of you using more on like excavating like that. Some of you may doing on more on different approach by we have a linkage to do like this, and it will go like that. We have a kinematic movement to convey the waste. Some of you will go for will throw idea go on something on channel also, but it's kind of like flow through gravity, maybe by shaking device, shaking mechanism. What is shaking mechanism? It conveying the waste through it goes downward, right? Maybe it's simple. This one is more simpler case. You have a lot of idea you throw because this what you call all of this is alternative, right? Alternative. Okay. Okay, alternative. Okay, separating the waste. How after we convey the waste, some of you using simple meshing, using meshing. So it means the waste, the plastic bottle, and the descent will be go downward based on simple what we call it filtering, right? Meshing. Separating the waste. Some of you based on suction tube. Based on suction tube, it means the sand will be, you just write it on the cell. You can use your marker, just write. Sometimes it have to be words, better to be schematic sketches on here. So because the idea is that all the other group member understand what idea you are writing on this cell. So everybody have to contribute. Separating the waste, some of you use another method of like screw feeder also separating the waste. So descent goes up, goes down, and the waste goes here. Some of you more on kinematic, something different mechanism. This one, the beach sand, the waste goes up, the beach sand goes down. Some of you based on kind of like a step approach, a shaking mechanism you take. This one is a shaking mechanism in kind of like separating the waste from the beach sand. So the beach sand goes down, the waste here. Some of you based on different approach of idea of using some robotic arm and so on. So the beach sand, the waste goes down, beach sand goes down, the waste goes there. Because this or separating the waste from descent. Then containing the waste. So okay, here about containing, some of you just a simple trash bag. Trash bag. This one is just we have a container inside. Some of you more on like this shape of container. This one kind like more different approach, more like a small plus a partition grid of box because that's idea of it. I mean the waste containing the waste, right? The waste, it kind of like, why the containing waste, it can contain separating, it can contain the bottle goes here, the aluminum can goes here, the plastic bag, this is much better. Some of you goes for different approach by, there is a system that you want to do, you just write it down. Some of you more on rolling element to containing the waste, to put the waste on the container, something like that. Alright, removing the descent is something just free gravity fall. Free gravity fall, it means it goes down. This is your system, it means the waste goes down. Some of you, this is your system, the waste goes in this direction, removing the descent. And this one just based on just a blower. You got blower to blow the descent to the ground. This one based on different approach of removing the descent from your system, because your descent need to be thrown out. And this one more on just a simple tunnel hole here. Okay, tunnel, and it means the descent goes down. This one is different kind of approach. Maybe you have a mesh grid to throw away the descent. Kelas, dari bila tak ada ni? Video tak ada ke? Senyap je. Kelas, can you hear me or not?
Boleh doktor, boleh. Hello. Hello.
Class, can you hear me? Tadi we have technical problem. I just noticed that the video was not on. Since when? Can you just reply chat here? Can you still hear me? Inform me. Since when the
No, just now. It's closed just now.
boleh inform saya ke? Can you hear me, guys? Macam mana saya tak boleh dengar suara korang? Class, can you hear me or not?
Yes.
Boleh, doktor boleh.
Boleh respon dengan saya ke?
Dengar doktor.
Alright. Berapa kerat saja respon, yang lain saya tak faham, senyap je. Okay, I think maybe my video up until what moment, you feel all, make sure everything is here. Containing the waste, we already have alternative here. Removing the descent from the way, we have alternative here. So it means you make sure that your morphological chart is full. Alright, okay, the idea of morphological chart is that once you have completed your morphological chart, it means, okay, now only you can independently, each group member can independently generate ideas. Understand me? Each group member, because the idea of this function decomposition and morphological chart is a systematic way for you, kind of like you to integrate your complete system into sub-function. So it becomes a complete function. A complete system of your device. So this, the one that I explained to you is about example of this cleaning device. So that's how we do things. So we already make this one. Because I add prime mover. So what is the source of power that will pull your device? So then only the flow of this is follow your flow of your function decomposition. All right. So you make a morphological chart. Then everybody have to contribute through idea, right? Make sure it is full. All the ideas thrown out here is kind like idea. It's not a rubbish idea. Understand me? It's not you understand what I mean by rubbish idea? Idea that is kind like useful ideas, useful or brilliant ideas, brilliant. Because based on all the knowledge you already gained before by reading the PDF and so on, right? So you throw out what is the possible ideas, right? So the idea of when your morphological chart is full, then only each group member can sit down alone, independently, do not depend. So from here, so you have a copy snapshot on this. So each group member have the same copy snapshot of this. So from here, each group can generate each group member. Each group member can independently, after you have completed your PDS, so this is a group work. So then the idea of this morphological chart, because you have okay, as I mentioned to you, at least 6 column, right? So we have 1, 2, 3, 4, 5, 6, 6 rows and 6 column. This thing, this one can give you unlimited numbers of alternative about your device. Understand me? Because if you learn about probability, you have, for example, this one is 6 column and 6 rows. So it means the idea when you combine idea, I want to do this, this. When you do a set or combination, it become a complete system, right? So it means that will be your idea one. So you want to do this. So this a complete system, your idea two. So another concept, this one. You understand in class? So I mean, from here, it kind like trigger you to generate your own concept. This is a systematic approach. So this is kind of, you have a lot of alternative because before this, you don't have any idea how to generate concept. So this is more systematic way to help you. This is not about concept. This is about all the possible idea we break down into sub-function. I mean, we are thinking more into more detailed sub-function, all the possible alternative based on what level we are throwing the idea. For example, collect the waste, convey the waste. So it trigger you to generate ideas. So from now, after you have completed the morphological chart, so each group member generate 3 concepts from here. For example, student A will do this because this one will trigger you. You are more interested on this. And another concept too, you will do this one, combine this one. And the another one you are more interested on doing this one. This is your third idea. Understand me, class? So each group member, 3 ideas. Each group member, 3 ideas. Clear? Paham, 3 ideas. Okay, so it means each group have 5 group members. So you have produced total group will be 15 ideas. All right? 15 ideas. All right. After you have done this, because next week you will do concept evaluation, because next week we go to face. Actually, I check out you frankly, guys. Design course ni, because I've been talking, it's not good to be handled online because I've been talking to you. I understand. I can see you. Even you are not on your camera, I can see you get bored. You don't understand what I'm talking about. But just watch, listen my video. Maybe if my video recording is good, there is no technical problem, I will share you this recorded video. That is hard to handle online. So better to be face to face. All right. So you have done complete your this one morphological chart. Each one of you from here, from the completed morphological chart, will trigger each of the group member to produce 3 ideas. That's why I mean 3 ideas each group member. All right. So then, okay, what you need to do? Then what you do? So, okay, are you still listening? After student A produce 3 ideas from morphological chart. Okay. Independently, student A can generate ideas. From morphological, you have a set of 3 combination. Okay. Combination 1, idea 1. Combination 2, idea 2. Combination 3, idea 3. I am talking about each group member. Right? Okay. Student A of the group, 3 ideas. Student B of the group, 3 ideas. Student C also produce 3 ideas. Right? 3 ideas. Student D also 3 ideas. Student E also produce 3 ideas, right? So total have 50. Okay, now student A have completed. You make sketch on small piece of A4 only. A4 only. So idea 1, A4 side, make a sketch about what is you're going to design, about your project. And student A also produce the second idea. Student A also produce third idea. So each group member 3 ideas. Understand me? It cannot be you have 5 group member, only 5. They mean each one of you 1 idea. I think that is not good. You have to produce a lot of ideas because you have unlimited numbers of ideas from here. All right. So I mean, okay, after all the group members have completed 3 ideas based on the completed morphological chart, you develop 3 ideas, simple A4 size. So you will conduct a brainstorming. Okay, this is what you need to do. Okay, brainstorming session is like this. I hope you are listening. Brainstorming session. Okay, brainstorming. Brainstorming It's not as brainstorming you are being thinking on. Okay, that is not typical common brainstorming. Brainstorming session mean, okay, if you are listening, I hope there is not technical problem. Still recording, you can hear my voice. You sit down around table, right? So that's what I want you to do. Okay, student A, there is student B, student C. Okay, student A, student B, student C, student D, student E. You have 5 of you, right? A, B, C, D, E. All right. Brainstorming session. Okay, you punya sketch number 1. Okay, 5 minutes. So A, send your sketch. You send, because you have, each one of you have 3 concept, right? Concept number 1, A, send the concept 1 to B. B, send the concept, okay. Everything, this is simultaneously done. It's not doesn't mean student A. So A, they represent everything. So B was give to C. C, concept number 1 of C, give to D. D, give to E. E, give to A. So I only simulate student A only, because it is run simultaneously. A give concept to B. 5 minutes. So B will read A either. So this is student A concept. So B, when we receive the student A concept, concept number 1, do not condemn, do not make a positive. You add something. Okay, this is a sketch of student A. B will evaluate. You don't have to condemn. So when you condemn, you put negative comment, it will kill the brainstorming session. So the rule of the brainstorming, do not condemn. Understand me? Do not condemn. Do not put negative statement. Do not put negative comment. You are saying, this is cannot work. This one cannot. This one will not work. This is a lousy design. Cannot be like that. You have to be give positive value. You make things better. Understand me or not? So you put when A sent to B, B make some improvement, make some value of the, okay, this is good. For example, you write something like this. This is good. The design is good, but reduce component, too complicated. But the design is good, but little bit reduced. Understand me? Okay, while A sent to B, B also send concept 1 to C. It goes like that, right? Okay, if I simulate only student A, okay, 5 minutes, then after B evaluate A concept, then after 5 minute break, then another one, B will send A, this is student A concept 1. This one, the student A concept 1 just now have been already evaluated by B and already have a statement positive value added by B, and student C, okay, D is student B evaluated, already mentioned. Then the second round, the second round, the B submit A to C. Then C will see student A concept have been positive value added by B. C makes some additive again. Then C do something. Okay, the design, okay, reduce component. Maybe you have any other. I think the wheel should be like this, and this one will make it better. C have made some positive value added. Then 5 minutes, the third round. What I mean, the third, I said the third round, the third stage. Then the C will give A concept 1 have been evaluated. This is on the original A concept just now, being evaluated by B, being evaluated by C, and now the D, do add more, give positive value. You have either make it much better of A concept 1. Understand me? Then the fifth round. So student A concept number 1 just now, been evaluated by B, a value. C already have added value. D also have value, and E now positive added value. Then after the then the fifth round, A will receive his concept number 1 being evaluated by B, by C, by B, C, D, and E. Clear or not, class? Positive value added. Do you clear understand or not? Class, signal me, do you understand or not? I need response. Cepat sikit.
Boleh. Understand.
Atau saya bercakap seorang dia tadi? Respond me. Any message?
Understand.
You
Understand.
understand or not? Someone please reply.
Yes, Doctor. Clear, very clear.
Can someone reply? Tak ada.
Understand.
Faham,
Okay,
Doktor.
Doctor.
Alright, good. Thank you, Megat. Okay. So that's how it works. So I simulate only the A, because remember A also have another two concepts, right? Each one of you. So this is a brainstorming session. But after you have each concept, you have 5 rounds. So while A giving B, B give to C. C also starting give to D. It going like this counterclockwise, right? While A is give to B just now, D give to E. Understand me? After 5 rounds, you will receive your original sketch. You receive back your original sketch being evaluated by 4 of your group members being positive value added. So, then you see, yeah, they are right. I should make this concept 1 better. I should make this concept 1 better. So you make improvement of your concept 1. But remember, this is concept 1. Each one of you have 3 concepts, right? So you have 2 more concepts to go through brainstorming session. Clear or not? So that's how it works. Clear the class. So this you will conduct. Hopefully, because I hope you can conduct this week if possible, because the next week, I think we need to do on the, next week, I need to see on the second meeting, the opposite, because next week we will go. So it means that what I need to do for you to accomplish before the second meeting next week, I give you ample time, not the first week, the second meeting next week. So I will see you. I need to see the result of it. So it means that each one of you, your concept number 1, concept number 2, and concept nothing have already, you make a modified version. Understand me? You make a modified version because you have done brainstorming session. After brainstorming, you mean brainstorming also done. Brainstorming also done. So this one concept your number. Each of the group member, this one is a concept 1, concept 2, concept 3, this already done. This concept is being evaluated. You make a modified. Okay, modified after, it's all the modified version. So many modified version after brainstorming session. Clear or not, class? Boleh? Okay, that's all I need to tell you today. I hope you understand. So you need to do function decomposition, right? Discuss with your group member, with your group. Then you make a morphological chart, throw all the possible cells. So from here, from completed morphological chart, it will trigger you to generate ideas. You have unlimited amount of ideas. You have a lot of combination to produce unlimited amount of ideas, right? And then each one of you will produce 3 ideas from this. Okay, so you have each one of the group member have 3 ideas, idea 1, idea 2, idea 3. So idea 1 must go through brainstorming session. Idea 2 also have go to brainstorming session. Idea number 3, I'm talking about each group member. I must go through brainstorming session. So this one runs simultaneously. I just simulate to you A only. While A to B, B start to C, C start to D, D start to E, E start to A. So after 5 rounds, you will receive back your ideas being evaluated, then you make a modified version. Yeah, this is the output. Idea number 1 modified, and number 2 modified, and number 3 modified. So I give you ample time. I need to see the output by second meeting next week. Can you do that? Boleh? Alright, class? So I think that's all for what you need to do, right? Since we are conducting online, so I cannot help it. So that's what all about, right? So because that's how you produce ideas. This one of the way. Okay? Okay, kalau tak ada apa-apa, since so I go for attendance. Any question you can ask me, because maybe there is technical error. I cannot see your voice. I cannot hear your voice. Okay, class, scan your attendance.